The engine screams like a banshee trapped in steel, its modified pistons hammering against compression ratios that General Motors never intended, never tested, never imagined would be necessary for anything other than complete mechanical suicide. Corporal Danny McLeod feels the Sherman tank's hull vibrating around him with frequencies that threaten to shake his teeth loose. Watches his speedometer needle climb past every red line the engineers painted to warn against exactly this kind of automotive madness. 43 miles per hour through the Ardennes forest in December 1944, ice and mud flying from tracks that were designed for 25 maximum, pushing a 30-ton war machine beyond every specification that kept it from destroying itself in spectacular fashion. Behind him, gaining ground with the methodical precision that German engineering brings to the business of mechanized warfare, a Panzer I-4 AUSF. H closes the distance with its superior power-to-weight ratio, its technically superior transmission, its carefully calculated balance between armor protection and battlefield mobility. The German tank represents 4 years of systematic improvement in armored vehicle design. The accumulated expertise of engineers who understood that wars are won by machines that perform consistently rather than dramatically, reliably rather than spectacularly. But Danny's Sherman represents something different, something that violates every principle of conservative military engineering in favor of desperate innovation, battlefield improvisation, the kind of mechanical modification that peacetime regulations prohibit because the risks exceed any reasonable calculation of benefit versus catastrophic failure. His engine modification should have destroyed itself within the first 10 minutes of operation. Instead, it's providing exactly the kind of impossible performance that survival requires when textbook solutions prove inadequate to address problems that textbooks never anticipated. The chase began 15 minutes ago when Danny's reconnaissance patrol encountered German armor advancing through forest paths that Allied intelligence insisted were impassable for heavy vehicles. The encounter should have ended with American withdrawal, tactical repositioning, radio calls for artillery support that might arrive in time to prevent German breakthrough into rear areas where supply convoys and headquarters units operated under the assumption that heavy enemy armor couldn't penetrate the natural barriers that the Ardennes terrain provided against mechanized assault. But Danny's engine modification has transformed retreat into something unprecedented. An American tank outrunning German pursuit through terrain that favors neither speed nor maneuverability, demonstrating that innovation can overcome technical disadvantage when innovation is crazy enough to ignore the limitations that sane engineering accepts as immutable facts of automotive physics. This is December 1944. The Battle of the Bulge has been raging for 8 days, teaching Allied commanders that German military capability remains far more dangerous than intelligence assessments suggested, that enemy forces retain the capacity for major offensive operations despite months of strategic bombing and resource depletion that should have eliminated their ability to conduct large-scale attacks. In the frozen forests of Belgium and Luxembourg, German armored divisions are demonstrating that reports of their demise were greatly exaggerated, that Tiger tanks and Panzer IVs and mechanized infantry can still penetrate Allied lines with the kind of tactical surprise that transforms confident defensive positions into desperate fighting retreats. Canadian armored units attached to American forces find themselves confronting the technical reality that their Sherman tanks, reliable and mechanically sound though they are, represent compromises between competing requirements that leave them consistently outgunned by German armor that was designed specifically for tank-versus-tank combat, rather than the infantry support role that American doctrine emphasized when specifications were established years before anyone understood how armored warfare would actually develop under combat conditions. The Sherman's 75mm gun, adequate for most tactical situations, proves insufficient against German armor that deflects American rounds, while returning fire with weapons that penetrate Allied armor with disturbing efficiency. Danny McLeod understands these technical disparities through direct experience rather than theoretical analysis, through months of tank combat that taught him exactly how much his Sherman could accomplish, and exactly where its limitations became life-threatening liabilities. A mechanic by training and temperament, he approaches armored warfare as a series of engineering problems that require mechanical solutions, technical challenges that can be addressed through automotive modification if regulations and safety considerations are subordinated to performance requirements that combat conditions impose on equipment that was designed under peacetime assumptions about acceptable risk versus operational capability. The engine modification that now propels his Sherman at impossible speeds began 3 weeks ago when Danny's unit received replacement power plants that had been damaged during shipping, engines with cracked blocks and damaged components that standard repair procedures couldn't restore to factory specifications. Military protocol required the damaged engines to be returned to depot-level maintenance facilities where proper repair equipment and qualified technicians could restore them to regulation standards or condemn them as total losses, requiring replacement through normal supply channels. But Danny saw opportunity in the damaged components, possibilities that regulation repair procedures would eliminate in favor of conservative restoration to original specifications. The cracked engine blocks could be welded and reinforced with techniques that violated warranty conditions, but might provide superior strength characteristics. The damaged pistons could be modified to operate at higher compression ratios that would increase power output at the cost of reduced engine life and increased maintenance requirements. The transmission components that had been stressed beyond design limits could be rebuilt with modifications that prioritized performance over longevity, speed over reliability. The modification process required 3 weeks of work that violated every principle of military maintenance procedures, every regulation that governed acceptable modifications to government equipment, every safety protocol that prevented mechanics from experimenting with expensive machinery using techniques that had never been tested under controlled conditions. Danny worked during off-duty hours, using salvaged materials and improvised tools, creating engine modifications that existed nowhere in any technical manual because no qualified engineer would have approved the kind of experimental work that peacetime regulations prohibited for excellent reasons related to safety, reliability, and the catastrophic consequences that resulted when automotive modifications exceeded the mechanical limits that manufacturers established through extensive testing. The welding work alone required techniques that military field manuals specifically prohibited, joining materials with methods that created stress concentrations and metallurgical problems that could cause catastrophic failure under the kind of operational stress that combat conditions imposed on equipment that was already operating at the margins of design specifications. But Danny understood that perfect engineering was the enemy of adequate performance, when adequate performance was the difference between survival and becoming another statistic in casualty reports that documented the technical superiority of German armor over Allied equipment that had been designed for different tactical requirements. The engine block reinforcement involved welding additional material to areas where the original cracks had compromised structural integrity, creating a hybrid power plant that combined factory engineering with field modification in ways that no manufacturer would have approved, but that provided exactly the kind of enhanced capability that combat experience suggested was necessary for tactical parity with German armor. The welding created stress patterns that metallurgical engineers would have condemned as structurally unsound, but the reinforcement provided strength characteristics that exceeded original specifications in areas where combat damage typically occurred. The piston modification required machining work that transformed factory components into experimental parts that operated at compression ratios exceeding design limits, generating power outputs that stressed every component in the engine system beyond the safety margins that conservative engineering had established to prevent mechanical failure under normal operating conditions. But normal operating conditions didn't include tank versus tank combat. At ranges where superior German armor and armament created tactical advantages that could only be countered through superior mobility, faster acceleration, higher top speeds that allowed American tanks to avoid direct confrontation while seeking positional advantages that compensated for technical inferiority in armor protection and main gun effectiveness. The transmission work proved most challenging, requiring modification of gear ratios and clutch systems that had been designed for reliability rather than performance, for consistent operation rather than maximum capability under extreme stress. Danny rebuilt the transmission with salvaged components and improvised parts, creating a power delivery system that prioritized acceleration and top speed over the mechanical longevity that peacetime operations required. But combat conditions made irrelevant when tank survival depended on tactical mobility rather than mechanical durability. The completed modification created an engine system that violated every principle of conservative automotive engineering while providing exactly the kind of enhanced performance that tactical situations required when standard equipment proved inadequate to address threats that equipment specifications had never anticipated. The modified Sherman could accelerate faster than factory specifications suggested was possible, achieve top speeds that exceeded design limits, maintain high-speed operation under conditions that should have caused immediate mechanical failure. But the modification also created reliability problems that peacetime operations would have considered unacceptable. Maintenance requirements that exceeded normal support capabilities, operational limitations that required constant attention to mechanical systems that standard Shermans could operate without specialized technical knowledge. The enhanced performance came at the cost of mechanical simplicity, operational reliability, the kind of foolproof functionality that military equipment required when operated by personnel who lacked specialized training in automotive modification and experimental engine technology. The first test of Danny's modification occurred during routine patrol operations that became extraordinary when his unit encountered German reconnaissance elements advancing through terrain that tactical assessments had identified as unsuitable for armored operations. The engagement began with standard procedures: radio contact with higher headquarters, tactical withdrawal to predetermined positions, coordination with supporting units that could provide artillery support, and air cover if weather conditions permitted close air support operations. But the German response demonstrated that enemy forces possessed mobility capabilities that Allied intelligence had underestimated, that Panzer units could maneuver through terrain that should have been impassable, that German tactical doctrine had adapted to Ardennes conditions more effectively than American planning had anticipated. When German armor began pursuing Danny's patrol through forest paths that narrowed tactical options to direct confrontation or desperate evasion, the modified Sherman's enhanced capabilities transformed the tactical situation from hopeless to merely desperate. The pursuit began when Danny's patrol encountered a German armored reconnaissance unit consisting of 2 Panzer IV tanks and supporting infantry advancing along a forest trail that Allied maps indicated was unsuitable for heavy vehicle traffic. The initial contact should have resulted in immediate American withdrawal, radio coordination with supporting units, tactical disengagement that preserved Allied forces for defensive operations from prepared positions where American advantages in artillery support and air cover could offset German superiority in armor and main gun effectiveness. But the German response to contact demonstrated tactical aggressiveness that didn't allow time for orderly withdrawal, mechanical reliability that enabled pursuit through terrain that should have prevented sustained high-speed operation, crew training that allowed German tanks to maintain accurate fire while maneuvering through forest conditions that degraded visibility and complicated target acquisition. The tactical situation deteriorated from routine patrol contact to desperate evasion within minutes, forcing Danny to choose between direct confrontation that favored German technical advantages or experimental evasion that depended entirely on his untested engine modifications. The decision to engage his modified engine system came not from tactical doctrine, but from practical calculation that direct combat offered lower survival probability than experimental flight, that his engine modifications might provide exactly the kind of tactical advantage that standard equipment couldn't deliver under circumstances that standard tactical procedures hadn't anticipated. When Danny engaged the modified transmission and felt his Sherman accelerate beyond factory specifications, he understood that he was conducting the ultimate field test of automotive modifications under conditions that would either validate his engineering work or provide spectacular demonstration of why military regulations prohibited exactly the kind of experimental modification he had spent 3 weeks developing. The chase through the Ardennes developed into something unprecedented in armored warfare history. An American tank outrunning German pursuit through terrain that favored neither speed nor maneuverability, demonstrating that mechanical innovation could overcome technical disadvantage when innovation was desperate enough to ignore the safety limitations that conservative engineering accepted as immutable constraints on automotive performance. Danny's Sherman achieved speeds that should have been impossible on forest trails, maintained acceleration that exceeded design specifications, demonstrated reliability that contradicted every prediction about the mechanical consequences of operating experimental engine modifications under combat stress. The German Panzer IV that pursued him represented the accumulated expertise of engineers who understood the relationship between power, weight, armor protection, and mechanical reliability, who had designed armored vehicles that balanced competing requirements through systematic testing and conservative engineering that prioritized consistent performance over experimental capability. The German tank was faster, more maneuverable, better armored, and equipped with superior armament. Under normal circumstances, it possessed every technical advantage that tactical doctrine suggested was necessary for successful armored combat. But circumstances had become abnormal when Danny's modifications transformed his Sherman from standard American tank into experimental vehicle that operated beyond design specifications, that achieved performance characteristics through field modification rather than factory engineering, that demonstrated possibilities that conservative automotive design had never explored because the risks exceeded any reasonable calculation of benefit versus catastrophic mechanical failure. The German tank crew found themselves pursuing an American vehicle that shouldn't have been able to maintain the speeds they observed, shouldn't have been capable of the acceleration they witnessed, shouldn't have possessed the reliability necessary for sustained high-speed operation through terrain that challenged even their superior mechanical systems. The tactical situation developed into a high-speed chase that violated every principle of armored warfare doctrine, that demonstrated possibilities that neither American nor German tank training had anticipated, that required skills and equipment capabilities that existed outside normal military specifications. Danny's Sherman raced through frozen forest at speeds that threatened mechanical destruction, navigated terrain that exceeded design parameters, maintained performance that contradicted engineering predictions about the operational limits of experimental automotive modifications under combat conditions. The pursuit covered 12 miles of forest terrain that alternated between narrow trails barely wide enough for single-vehicle passage and small clearings where tactical maneuvering became possible, where the German Panzer could employ its superior armament if range and visibility conditions permitted accurate fire. The German tank crew demonstrated exactly the kind of tactical proficiency that 4 years of armored warfare had developed, maintaining pursuit despite terrain challenges, coordinating movement with supporting infantry elements, employing fire and maneuver techniques that should have terminated the chase through superior tactical execution rather than extended mechanical pursuit. But Danny's modified Sherman continued to demonstrate performance characteristics that exceeded every prediction about the mechanical consequences of operating experimental engine modifications under conditions that combined maximum stress with minimum maintenance, combat operations with automotive innovation, desperate tactical requirements with unproven engineering solutions. The tank maintained speeds that should have caused immediate transmission failure, achieved acceleration that should have destroyed the modified engine system, sustained high-performance operation that should have resulted in catastrophic mechanical breakdown within the first few minutes of maximum effort. The German crew began to recognize that they were pursuing an American tank that possessed capabilities that German intelligence assessments had never identified, that demonstrated performance characteristics that contradicted their understanding of American armor limitations, that suggested technological developments that German technical analysis had failed to anticipate. The Sherman that raced ahead of them through terrain that challenged their own superior mechanical systems was achieving impossible performance through unknown modifications that transformed American technical disadvantage into unexpected tactical capability. The breakthrough moment came when Danny's Sherman achieved sufficient speed advantage to break visual contact with German pursuit, disappearing into forest terrain that allowed tactical disengagement rather than continued flight, reaching friendly lines where radio communication could coordinate artillery support and air cover that transformed the tactical situation from desperate evasion to successful reconnaissance mission that provided valuable intelligence about German armor capabilities and tactical intentions in the Ardennes sector. The debriefing that followed Danny's return revealed the full implications of his engine modifications for Allied armor operations in terrain that favored mobility over protection, speed over firepower, tactical innovation over conservative doctrine that assumed American technical disadvantage was permanent limitation rather than engineering challenge that could be addressed through field modification and experimental automotive development. The performance characteristics that his modified Sherman had demonstrated suggested possibilities for upgrading existing equipment that could offset German technical advantages without requiring complete replacement of American armor through manufacturing processes that couldn't provide new equipment fast enough to influence current tactical situations. The technical analysis of Danny's modifications revealed engineering principles that violated safety regulations while achieving performance improvements that exceeded factory specifications, automotive innovations that prioritized capability over reliability, while demonstrating that mechanical limitations were often administrative rather than physical, that conservative engineering served peacetime requirements, that combat conditions rendered irrelevant when survival depended on maximum performance rather than optimal safety margins. Military engineers began studying Danny's field modifications to identify techniques that could be incorporated into standard maintenance procedures, performance improvements that could be achieved through approved modification programs, engineering principles that could influence future armor development without compromising the mechanical reliability that military operations required when equipment operated under conditions that exceeded design specifications. The welding techniques, piston modifications, and transmission work that Danny had developed under combat pressure provided foundation for official upgrade programs that enhanced Allied armor capabilities during the final months of European combat operations. But more importantly, Danny's success demonstrated that technical limitations could be overcome through innovative field modification when innovation was desperate enough to ignore safety considerations that peacetime engineering prioritized over performance requirements, that mechanical ingenuity could address tactical disadvantages, that doctrine accepted as permanent constraints on operational capability. that one mechanic's refusal to accept engineering limitations could influence armor. Development and tactical procedures for decades beyond the immediate combat situation that motivated his experimental work. The war ended 5 months later. Danny returned to Canada carrying technical knowledge that proved valuable in the post-war automotive industry, where rapid development of civilian vehicles required mechanics who understood both standard maintenance procedures and experimental modification techniques, who could adapt existing equipment to meet performance requirements that manufacturer specifications hadn't anticipated. His wartime experience with engine modification influenced his post-war career in racing and high-performance automotive development, industries that required exactly the kind of innovative approach to mechanical limitations that combat conditions had taught him to employ when survival depended on achieving impossible performance from standard equipment. The principles that Danny discovered under combat pressure, that mechanical limitations are often psychological rather than physical, that innovation emerges from necessity rather than comfort, that performance improvements require willingness to accept risks that conservative engineering prohibits. These lessons proved applicable far beyond tank warfare. They influenced automotive design philosophy in industries that required maximum performance under extreme conditions, where reliability had to be balanced against capability, where safety considerations had to be weighed against operational requirements that standard equipment couldn't satisfy. The Ardennes forest remembers nothing of the high-speed chase that demonstrated how field modification could overcome technical disadvantage, how desperate innovation could achieve tactical advantage, how one Canadian mechanic's refusal to accept mechanical limitations influenced armor development and military doctrine. The trees that witnessed Danny's Sherman racing through terrain at impossible speeds show no permanent evidence of the moment when experimental automotive modification proved that technical superiority could be challenged through engineering innovation, rather than accepted as permanent tactical disadvantage. But sometimes, when modern tank crews conduct high-speed operations through challenging terrain, when automotive engineers design high-performance vehicles that operate beyond standard specifications, when mechanics face mechanical problems that require innovative solutions rather than textbook procedures, they reference the story of the Canadian mechanic who modified a Sherman engine to outrun German armor through frozen forest, who proved that innovation begins with the willingness to ignore expert opinion about what is and isn't possible when survival depends on achieving performance that exists outside normal specifications. The engine modifications that Danny developed under combat pressure continue to influence automotive design in applications that require maximum performance under extreme conditions, where standard equipment must be enhanced through field modification, where mechanical innovation provides the only alternative to accepting technical limitations that competitive situations render unacceptable. Racing teams study his welding techniques. Military mechanics employ his modification principles. Engineers reference his work when designing systems that must operate beyond factory specifications while maintaining the reliability that mission success requires. If stories like this remind you that mechanical limitations exist mainly in the imagination of engineers who prioritize safety over performance, that innovation emerges when necessity meets ingenuity, then perhaps there are other moments when refusing to accept impossible created breakthroughs that changed how we understand the relationship between engineering constraints and human determination to achieve what technical specifications insist cannot be accomplished.